Okay, suppose you have before you two urns containing balls of different colors. Let's say that in the first urn we have black and red balls, and in the second we have red and white balls. And a prize is awarded if you draw a non-red ball from either of these urns. Let's say as well that the first urn contains 50% red balls, the second urn contains 25% red balls. Which of these two urns will you choose to draw from? Well, I don't think there's any doubt about what the correct answer is in this case. You should draw from the first urn because this one contains more red balls, or a higher proportion of red balls, to be more precise, than the second one. Okay, well now suppose that you get different prizes depending on whether it's a black ball or a white ball that you draw. Let's suppose, to be more specific, that a white ball carries a prize 4 times as great as a black ball. Suppose a black ball, for instance, pays £1 if you draw it, and a white ball pays £4. Well, now your decision problem is slightly more difficult, but I think it's still fairly obvious what you should do. Although the proportion of white balls relative to red balls is much greater in the second urn than the proportion of black balls to red balls in the first urn. In fact, the proportion is twice as great in the first case as in the second. The prize is worth 4 times as much. So when you balance these two things out, this time clearly the right thing to do is to pick the second urn. All right, so that all seems very clear. But you may ask, well, how does this help? I mean, aside from perhaps helping you with making situations dealing with decisions in casinos and so on, it doesn't seem like the model that I've just presented of a decision problem is terribly relevant to anything outside in the world. And that's true, but with very little extra tweaking, we can make it much more relevant. Because what matters here is not so much whether we're in a situation in which proportions of balls or something like that are given, but whether we're in a situation in which we can make judgments about how likely one or another possible events are, whether it's likely that it's going to rain or not rain, whether the traffic is going to be heavy or not heavy, and that we can make some judgments about how valuable the prizes are, where the prizes here out in the world will be, things like owning a car or going to the beach or spending some time with friends and so on. And we can apply basically the same method to our decisions here. That is, we look at what the outcomes of the various decisions we can make are. Will we end up spending more or less time with our friends? Will be at our appointment, or will we be stuck in traffic jams and so on? And we can balance that out in the same way that we balanced the relative value of the prizes with the probabilities of the events which determine whether we get these events or not. And so there's a sort of sense in which many of the decisions which we make look very much like taking gambles. We're comparing gambles. Every time you, for instance, cross the road to buy bread from the bakery on the opposite side, you are in effect entering a lottery. You're thinking about what the probability is of being hit by a car as you cross. You're deciding whether that probability is sufficiently low, that it's outweighed by the good of the bread that you will be able to buy in the bakery on the other side. And you're comparing that with various other possible lotteries that you could enter into and deciding which of those is worth most to you. And in fact, this kind of way of thinking about decision making is enormously general and enormously powerful. So general and powerful that the theory, which is in technical language called the theory of maximizing expected utility, is used throughout the social sciences, particularly in economics, but also in the other social sciences and in philosophy. And it's become the gold standard, as it were, for rational decision making. But notice that even once we allow that the probabilities that we assign to the various events, the values that we assign to the various possible consequences, may not be given to us, but are based on judgments, and these judgments may be more or less subjective. Even once we grant all of these things, we have to recognize that there's still something slightly idealized, or not slightly, I would argue, something quite idealized about the way in which we conceive the decision problems that we face. And here are these sort of important idealizations that we make. Firstly, we assume that we know what our options are, that we know how many urns there are to choose from, for instance, if you like, or whether the alternative is simply crossing the road or not crossing the road. We assume that we can form a fairly definite judgment about how probable the relevant events are. We assume that we can form a fairly definite judgment about how valuable the possible outcomes are. And we also assume that we have a fairly definite opinion about the way in which these things depend on the decisions that we make. And all of these things, while perfectly justified in some circumstances, are in many others not at all justified. If you think, for instance, about examples like, if you think, for instance, about technological change, which is, I think, a kind of area which demonstrates amply just how idealized this are. If we think about the mobile phone market, for instance, 20 years ago, I don't think anybody could have had anything like a reasonable opinion about the likelihood that we would all be walking around with iPhones in our hand, downloading material from the internet at will, finding our way to appointments by use of a map on a screen. The growth of technologies like that are, if not impossible, unpredictable in principle, certainly in practice are completely unpredictable. There are also many technological innovations which illustrate the point about us not being aware of what the alternatives are. Somebody deciding to invest, for instance, in the telecommunications market 20 years ago would really have no idea what the alternatives are over the next 50 years. There's also, I think, many cases in which we're clearly uncertain about what value to attach to things. I mean, in the sort of hard problems that we face, we don't know how to balance out, the loyalty that we have to our friends, to perhaps the sort of interest that we have in pursuing our own pleasure versus the commitments we feel we have to, maybe our sporting team. There can be many, many things that we regard as valuable and be completely unsure about how to balance these things out. We're sure they're all valuable, we're not sure how they stand up relative to one another. Now, these kind of problems, I think, are not at all special. I mean, the technological changes is sort of clearly ubiquitous, but there are also a sort of range of other problems that exhibit the similar kinds of features, two of which have become especially relevant in the last few years that were worth mentioning. One is the behavior of the financial markets. The fact that the cream of the financial and economics profession was unable to anticipate the credit crunch, for instance, a couple of years ago, shows just how hard it is, in principle, to make decisions in the light of definite probabilities about events, because there are these events which have enormous consequences for which people essentially had no probabilities. If they had attached probabilities to them, they would have taken some actions which have hedged against these possibilities, but they didn't. And these were, serious, rational people who failed to do this. A similar example is the kinds of decisions that we face around climate change, where we really have tremendously little idea about how the climate system works and what the long-run consequences are of certain things that we could or couldn't do. Here again, the technology question comes up again, because there are various possible things that we are being proposed, and there are other things that might be invented that would help us to deal with it, but we really have no idea what the effect of these things are. And so the kind of decisions that we need to take in environments like this, which perhaps really are the normal environments, not the special environments at all, are ones in which our standard theory doesn't apply, or it doesn't apply neatly. Now, there are things we can do. We can think about other ways in which we can represent the kind of uncertainty that we have here. If our uncertainty isn't just a matter of attaching different probabilities to things, but is much deeper than that, we might think of working with sets of probability functions. Correspondingly, we might work with sort of sets of possible values. And then we can ask ourselves, well, given that we've got a set of these things, can we weigh them up and so on? But fundamentally, we're just at the beginning here. I mean, there are lots and lots of questions about whether we should be cautious, or more cautious when there's severe uncertainty. Perhaps we should be bolder when there's severe uncertainty, because technology may resolve some of our problems. We have these questions, but we don't have answers, and yet we know that finding answers to these questions is tremendously important, because many of the great problems that we face in the current conjuncture depend on being able to say something about what we should do under these kinds of circumstances.